Hey everybody, welcome back to the channel. This week we're going to go through the 8 steps that it takes to lay out an electrical system when you're doing a van conversion. So starting from the beginning, the first step, and probably the most important step, is listing out all your electrical devices. So what I've done is I've created a spreadsheet here that shows every single thing that's going to use electricity in our van. Now this doesn't include the engine or any of the van lights, the headlights, anything of that nature. It's only what's going in the conversion, except for one exception, but we'll get to that later. So listed out everything. We've got the lights, for example, a couple different lights in a couple different places. We've got our SPAR diesel heater, our max air fan, our rooftop air conditioner. We've got water pumps, gray water dump valves, solar charge controllers, some battery monitors, our inverter, because it actually is the heart of the electrical system aside from the batteries. We've got water tank level indicators, we've got refrigerators, microwaves, water heaters, and where our shore power comes in. So the main thing is, once you get all of them in a list, then comes step 2. And that's sorting out the list between alternating current and direct current. So basically, what you would find in your house, like a normal receptacle, that's what's called alternating current. And that's usually around the 120 volt range, and it powers your typical household appliances. On the other side, there's DC, or direct current, and that's like what your car runs off of. It has a DC battery that's typically around the 12 volt range. Now there are things you can do a 24 volt system if you like, but that requires step up and step down inverters. And just for the sake of keeping things simple, we're not going to go into that today. One thing that you'll find in a van is you want to try to keep most things on the DC side, because everything that you run on AC has to run through your inverter. And the inverter, as you get to a more powerful inverter, the price starts to increase exponentially. So if you can keep everything on the DC side and only need an inverter for some of the time to run smaller items, you'll do a lot better than if you try to run everything on AC and max out the inverter all the time. That brings us over to step number 3, which we've already kind of talked about, but that's finding out how much power you're going to use in your van. So you've got your list, you've got it separated out from AC to DC, and now you want to know how much power you're going to be using. So in my spreadsheet here, what I've done is I've created a voltage column, that's AC, DC, 12 versus 120 volt, and then I've looked up the maximum rated amperage draw for every device that I'm using. And now this is it's going a little bit overkill here, because you're not always going to be pulling the maximum amount of amperage from every device all the time. But if you design to the maximum, then you'll have some cushion for different variances from day to day. Once your battery charge is not as good as it once was, you don't want to design it right to that limit and then realize, oh no, I don't have enough power. So you want to try to have a little bit of a cushion in there, and that's why I use the maximum rated amps for the devices that I'm using. So we've got voltage and we've got amperage, and now I need to figure out the power consumption. So that's a simple calculation. Volts times amps gives you watts, which is power. So from there, you need to figure out how long each device is being used. And I broke mine up in days. I mean, you could do whatever time interval that you'd like, but to me, I wanted to know how many days I could make it on the batteries, how many days I could make it on solar, how many days I could make it if I was plugged into a shore power connection at a campground. Hopefully forever with that connection. Then I made another column on my spreadsheet, and that's the time used per day in hours. And basically what you can do there is take your power in watts multiplied by your times used per day in hours, and then divide it by 1,000, and that gives you kilowatt hours per day. And so kilowatt hours is a common electrical unit. It's actually what the meter at your house runs off of, so the electrical company can figure out how much to bill you. So once you have that figure there, that gives you a number of how much power you're using every day. And the other thing is, if you have your solar panels, and if you do decide to tie your electrical system into the alternator on your van, and you have the shore power input, you can figure out how much power you can bring in on any given day. So that'll help you find the balance between just using straight batteries down to nothing and then having to plug into shore power, or if you put a certain amount of solar panels on the roof, then you can say, okay, well, I'm going to bring in X amount of power from the solar panels, and if I tend to drive an hour a day, I'm going to charge at this much throughout that drive. And that'll give you a better feel for how much you're bringing in every day. And if you're planning on going from campground to campground and plugging your van into shore power, maybe this isn't something that really matters that much, because most of the time you'll be running off shore power and it's probably going to keep your batteries topped off. But in the event that you're not, you need to know what the most power that you're bringing in. So for solar panels, they typically are sold based off of the power in watts that they bring in. So you can get a 350 watt panel, for example. Now, that's the advertised power that you're going to get. And on any given day, the angle of the sun, the intensity of the sun, if there's cloud cover, 350 watts is the best you're absolutely going to get. So that's if you're basically at the equator at 12 o'clock midday and the sun's straight overhead beaming straight down on it, and your panels are staying cool, which if you think about it, sun equals hot, which makes your panels hot. So it's kind of, you almost never get to that 350 range basically. So if you want to be conservative, you could take, say, 65 to 75% of that number and use it for your calculations, and that'll give you a pretty standard number for your solar panel input from your solar system basically. And so in my particular case, I was looking at 350 watt panels, and so instead of using 700 for my number, I was a little bit on the hopeful side, and I used 670 watts coming in. And I basically estimated on average that maybe 10 hours a day, and that's in the summer. That might happen. In the winter, that's probably not likely. But that's, once you get your spreadsheet laid out, you can play with the numbers and see where you need to be basically. And so in our particular van, it's an 04 T1N. It actually came with a house battery that is connected to the alternator already. It has a relay that disconnects it when the ignition is turned off, so you don't drain your starter battery by running all your equipment inside the van. Which, if you're going to do that and your van didn't come stock with a house battery, you definitely need to make sure you have that disconnect there. Otherwise, you will drain your start battery, and then you will not be going anywhere in your van until your solar panels charge it, maybe, if you're lucky. That's one thing. And our van, it has a 90 amp alternator on it, so I assumed that we're going to drive probably an hour a day, so I've got that much power coming in from that. And in our case, the air conditioner is the biggest load on the system. So that brings us to the next point. We've got an AC unit that takes up a lot of power, and so that was the driving force for us to go with a 3000 watt inverter, because when the AC kicks on, it's gobbling up almost everything that inverter can put out. And yes, we know that we can't run the AC on the batteries all day long. Yeah, it would be nice, but free energy doesn't exist. So we're estimating that we might use the AC for an hour or 2 hours if we really need it, if we're not hooked up to shore power, which most of the time, if we're going to be running the AC, we're going to be hooked up to shore power. So that's a thing there. I mean, you could put a ton of batteries in and run off batteries for a while, but that's not really the route we wanted to take. Getting the inverter size correctly, you can look at your most energy consumption, or your highest energy consumption item, and size it to that, but you also have to think about whether you're going to be running multiple items at one time. So if you're planning to run an electric hot water heater and an AC unit, and you want to use your NutriBullet to make smoothies in the morning all at the same time, that's probably going to overload your inverter, and you're going to have to plan out when you do these things and when you use which items, basically, and for how long you use them, so you don't have this situation where you overload your inverter and don't have enough available power to run all those items. So that's one thing to keep in mind when you're trying to size your inverter. You can basically just go down your list and add up all the power column in watts and say, okay, well, I need to be here for my inverter. And you'll probably find that you might want to cut some things off your list. I know that's what we found when we started adding up everything. It got to be a lot really, really quickly. So that kind of leads us into step number 4 here. And that's sizing your battery bank and picking the right amount of solar. So the way that I approach that is I looked at the total generated kilowatt hours in a day, and I looked at the total consumed kilowatt hours in a day. And right now I've got that ratio almost 1-to-1, so I could run pretty much all day long and not use any power from the battery bank. Like, I would be replenishing it at a rate that would keep the batteries above 85% pretty much all the time. And that's something I'd really like for the rig to be completely off-grid, like self-sufficient, only have to come in for water basically, and even at that might put a water filter on it so I can fill up from streams, rivers, that kind of thing. But that's another topic for another video, obviously. In our particular case, it looks like we're going to consume about 7.7 kilowatts per day, or kilowatt hours per day. And that's with running the AC, and I think I have the heater. Yeah, the heater's actually in there as well, put together, which I'm not going to run the heater and the AC at the same time. So that's something you can play with in the spreadsheet, basically, to get your numbers to do what you want them to do. And this is just you're making the assumption that you're going to use these devices for the guesstimated amount of time every day. So it's obviously going to fluctuate a little bit. So that's why 1-to-1 is really close. I'm looking at probably trying to get to like a 1-to-1.5 ratio, where I'm pulling in 1.5 times more than I'm going to use. So if I do run into a case where I need to run the AC longer, or want to take 3 showers with hot water in the hot water heater, it won't be like, oh, well, you can't do that today because you don't have that amount of power. So that's something that the ratio of total generated to total consumed, you definitely don't want to be less than 1-to-1, because then you're going to be just steadily bringing your batteries down all the time. You're going to have to plug into shore power to keep going, basically, which is something that personally we want to avoid in the van. So moving on to the battery bank sizing. That's something, basically, you can do a conversion between kilowatt hours to amp hours. And the thing that you have to be careful of there is when you do that conversion, it really matters what voltage you're going from and going to. So with a 12 volt battery bank, we're looking at a total consumption per day of roughly 650 amp hours. And that's just my first run through the spreadsheet, like I've said. And I really don't want to put 650 amp hours worth of batteries in the van. One, because I'm looking at doing lithium to cut down on weight, because we got an older van and it can't carry as much as the newer vans. And 650 amp hours of lithium batteries is a lot of money. So I'm probably going to be around the 400 amp hour range, and that would mean that if we weren't bringing in any power at all through the panels or the alternator charging or a shore power hookup, I'd have to be fairly conscious of the electricity that we're using because we would run out basically. But I do plan on leaving some extra space, so in the future, if I wanted to upgrade from 400 to say 600 or 800 amp hours, I do want to leave that option in case we just find that we really need more energy in the van. So that pretty much goes through the thought process that I used in order to map out how much electricity we're using per day, how much electricity we're generating per day, and the ratio associated with total generated and total consumed, and how that relates to how many batteries we want to carry on board. So now that we've done all the math and the hard part and basically a lot of the electrical engineering, and that brings us to step number 5. And that's actually laying out where the components are going to go in your van. So for us, we did a complete model in SketchUp that has all of our van basically laid out in a model with lights and cabinets and a bed and a shower and all of the features that we thought we wanted in our van. And to me, that's a really good way to spatially lay something out and see what it's going to look like. We did also tape it out in the actual van, like laid it out on the floor with blue tape and walked around and said, okay, maybe we need a light here, the fan's here, things like that. That helped us kind of get a feel for the space in the model. If you'd like to check out our model, we did do an overview on that. So if you want to click on the link up here, it'll take you to the overview there. Make sure you hit control when you click on it so you stay on this video and get all the good last couple of steps that we're going to go through here. So the overall layout of the components, I mean, basically a lot of your lights go in the ceiling. The under cabinet lights are pretty popular. I've seen a lot of the toe kick lighting it's in a lot of vans these days, so that might be something that you want to look at. But definitely don't think that just overhead lighting is going to be enough in your van, because I've been doing a lot of research. I've kind of been playing around in our van with how much light moves around in there. And if you only have 3 or 4 lights in your ceiling, there's going to be shadows, there'll be dark spots. You might have that cave-like feeling that you probably don't want to have if you're going to be in a van for a long period of time. So definitely put some under cabinet lights. The toe kick lighting, again, is a really cool feature. Aside from the lighting, you need to lay out where your main components are going to be. So your inverter, your battery, your solar charger, obviously your panels are going to have to be on your roof, so you're going to have to bring those guys in through the ceiling. Your fans, your AC, all that stuff you need to know about where it's going to go. And once you know that, you can kind of take like a spatial overview of the area and then start to zero in on actually where components are going to mount, like where your water heater is going to go if that's electric, all kinds of different things. And one thing not to forget about is your shore power connection. So on our van, we're actually going to put it out of the bottom of the van. So on to step number 6. And step number 6 is actually making a decision of whether you want to run your electrical through your walls, through your cabinets, or creating a conduit for it that's exposed. So there's a couple schools of thought here. I've seen a lot of people do it a lot of different ways. Personally, the way that I'm going to do it is run most of my electrical through my cabinets. And the reason that I'm going to do that is because I'm planning on spray foaming insulation inside the van. So once you spray foam it, it's basically you get it right one time and you don't get any more chances. Because if you don't get it right, you have to cut out the spray foam and then re-spray foam in, and it'd just be a big nightmare. So in the places where I can, I'm going to run it through my cabinets. And like when I have to bridge the gap from like say the cabinets down to underneath the bed, I will run some conduit in the wall there when we spray foam, so I will be able to pull wires through that place there, because I don't want to have exposed wires or an exposed conduit on the outside, or I guess really on the interior of the van that you can see, because it's kind of an eyesore, and really would like to go for a clean look. So on the other hand, if you're doing fiberglass insulation, wool insulation, reflectics, that kind of stuff, it's a little easier to run the wiring through the walls. Now, if you ever do need to work on it, you obviously have to either cut a hole in your wall or take your paneling back down. So that might be something that you want to keep in mind too. So that the more electrical that you can run through your cabinets and kind of just hide in the back of the cabinet, the easier it is to get to something and diagnose it if you have a problem. And for me, I've done a lot of electrical work on engines and boats, all on the marine side, and trying to diagnose wiring when you can't get to it is one of the most frustrating things I've ever had to do. So that's why personally, on our van, we're going to run as much as we can through the cabinets to make it where if we need to get to it, we can. Because the last thing we want is something to malfunction and we can't get to it to fix it without ripping out half the van. We have to cut the trip short, come back and fix the van. That's what we want to try to avoid. Basically, once you've got your components laid out and you know whether you want to run the wiring through the walls, through the cabinets, both, through conduit outside, then you need to start measuring where the wire runs in the van. And that's step number 7. So to do this, you can take a tape measure, you can use a piece of wire itself and run it where you need it, and then measure it, and then repeat the process for every wire you need to run so you can get a feel for how much wire you need. I'm not a huge fan of just ordering a ton of wire and then throwing a bunch of it away, because electrical wire is not cheap and it's not something that I want to just waste basically at the end of the project. So to me, measuring out the runs in advance, figuring out where everything's going to go, having a plan laid out, having a model or a sketch, something to go by, something you can record which links you need for which runs. To me, that's the way that I'm going to do it in our van to minimize waste and minimize cost. And that leads us into step number 8. And step number 8 is purchasing 1, the correct wire size, and 2, the right length of wire. So we've already covered the length part, and now we're going to go into the correct size. So in order to figure out the size of the wire that you want, you first need to look at the load that's going to be on the wire and whether it's AC or DC. In the AC world, you typically use what's called 12-2 or 12-3 wire for general 120 amp circuits. So 12 is the gauge, which is the thickness of the wire, and that correlates to the amount of current that you're going to pull through the wire and the length of the wire. So there's standard tables that you can look up. It's an AWG wire gauge table will tell you if you have X amount of load, which means the rated amps that you're going to pull through the run. And then if you've already measured out your links, you'll know, okay, here's my longest run, and I'm going to pull the most current through this run, and it's the worst case scenario basically. And then you can take that information, go to the AWG sizing table, and figure out what gauge wire you need to pull. And so the second part of that, the 12-2 or 12-3, that's the number of conductors that's in the wire. Usually it's all jacketed together and ready to be run through walls and everything basically. So for typical household use, 12-2 is pretty standard. That's 2 conductors and a ground. Now if you're running 240 volt or anything of that nature, that's when you get into the 3 conductor type wire. But for van purposes, more than likely a 12-2 is going to be a pretty standard wire gauge and number of conductors for what you're trying to do. So on the DC side, there's 2 conductors, a power and a ground. And basically in our van, I've looked at the maximum length of the runs and the most amperage that we're pulling on a DC circuit, and it looks like I'm going to try to run 16 gauge through the entire van to meet the amount of current that we need to pull on any of the DC circuits. That wraps up all 8 steps of laying out an electrical system in a van. If you've got any questions or comments, please drop them below. If you liked the video, give it a thumbs up. And if you're ready for more, hit that subscribe button and we'll be back next week.